B.Sc, I welcome you all in my channel Chemistry, the Mystery of Molecules. Today we are going to discuss an MCQ presented in front of you. So I request you please pause the video and try by yourself. Okay, now let's discuss. So this reagent is given in presence of this condition. What is the product? You have to find out. So before going to discuss, we should learn about the nature of the reagent. Means in this case two reagent. One is p-TSA, p-Toluenesulfonic acid. What is the role of this reagent? This is simply an acid. You can consider it's an organic analog of sulfuric acid. Okay, so it's a very strong acid. So it will give proton to somewhere where basic sites are available. Basic sites means where the sites which can bind with proton efficiently, like oxygen. And in this case two types of places are available. One is this ester moiety, or better to say lactone, and another is epoxide. By the way, both are possible to bind with, but remember that binding will result in conclusion where the corresponding energy of activation for the particular process is low. Okay, now so in this case what will happen, let's discuss. And another thing, the another possible option is that this alkene double bond, but remember the alkenes are soft base whereas oxygens are hard base. So according to hard soft acid base principle, oxygen will prefer to bind with the proton at this condition. Now what is the mechanism of this process? What happens? This proton will bind with this epoxide oxygen, and by the way I have already discussed that epoxide ring opening under acidic, basic or neutral condition, so you may better visit that thing for better understanding. Now you can say that, sir, this oxygen, better to say this carbonyl oxygen of ester can go protonation more efficiently. Yes, that's true, but that will not result any conclusion. I shall explain later on. Now so what will happen? This oxygen will be protonated here, and after protonation the question is someone will attack. In this case this double bond will attack. Why? Because neighboring group participation. Now this double bond will attack, and after the attack the corresponding either this or this carbon became cationic. Now fine, you can see this carbon is secondary and this carbon is tertiary. So we know that tertiary carbocations are more stable. So from here we can understand that double bond here carbocation, so bond formation will happen from this side, means from here. Now this side will attack to the epoxide. If it attacks to here, number 1, then it will be a 4-member ring, but if it attacks here, this place, it will be 5-member ring. So from there we can say that attack will happen from this to this. So if this attack happens from this to this, what will happen? This will open up. Fine. And remember, 5-member ring formations are easier due to proper conformational orientation. Similar thing is observed for 3-member ring also. So a 5-member ring will form and epoxide will open. So, and when such kind of situation arises, student, I suggest you please write the structure as it is. What do I mean by the statement? So write the structure as it is. Now here methyl is above and this hydroxyl down, agree. Now attach this, here one methyl group and here positive charge, fine, and keep everything other groups, everything as it is. Okay, so this is the overall thing you should write. So this is the structure. Now we have understood this. Now if you draw it properly, it will look like this. Fine. Now so one case 7-member ring, one case 5-member ring, and the positive charge on the tertiary carbon. You remember the tertiary carbocation are most highly stable due to this plus I effect as well as hyperconjugation, and in this case 2, 1, 3 and 3, 6 hydrogens are involved in hyperconjugation. Now in the next step what will happen? The alkene, the proton from this carbon will be abstracted and alkene will be produced. Okay, this alkene. Now question is that why the alkene forms here? This proton can have alkene, could be from this side also or from this side also, like exocyclic. But if in this case why this happens? Remember, when alkene formation from carbocation happens through elimination, the transition state is alkene like, and we know more stable, more substituted alkenes are more stable. That's why more substituted alkenes forms preferentially. Okay, Now the question which we didn't discuss, that why the hydrolysis of ester didn't occur in presence of very strong acid. We know that very strong acid are efficient for ester hydrolysis, but in this case it's not happening. Actually hydrolysis, if you look at the word, hydrolysis means water should be there, lysis means breakage in presence of water, but remember the condition p-TSA and DCM, no water there, so how hydrolysis will occur? This will not occur. So please be careful about the reaction condition. Now another question, why did the other bond didn't form like H plus elimination, as I explained, because the product is alkene type and in this case this alkene is more substituted. Now, so what is the answer of this question? Answer of this question is, first of all, 5 member and 7 member. This is. Now if this question appear in your exam, how can you solve this question less than 60 seconds? First of all, you need to understand there is a p-TSA DCM. Now two option possible, here will happen but no fault, no consequences, but in this case if protonation occurs, neighboring group possible, and another thing, 5 member ring formation more conformational easier and carbocation will generate at this center, understood. So where 5 member and 7 member are there, only one, so you don't need to think more, just this is the answer. Okay, so in conclusion, what you have learned, protonation reaction may occur in many basic center, but ultimately more stable product will be produced when where the corresponding energy of activation is minimum. And second thing, protonation and oxygen is favored over carbon-carbon double bond because oxygen is harder, carbon-carbon double bond is softer, means the HSAB principle, hard soft acid base principle. Tertiary carbocations are more stable than secondary, and 5 member ring formation is more favored over 7 member, actually better to say. And another thing, ester formation, ester opening by nucleophilic attack, possible if there is water. Okay, so this is the end of this discussion. I thank you everyone for watching this video. Please like, comment, share and subscribe. Stay happy, stay blessed. See you in my next video.